This is number 17 from section 7.4. It's already factored in the denominator for us, and the numerator has a lower degree than the denominator. So we are ready to do partial fraction decomp. So let's focus on a good guess for what is inside of there. So we're going to have a term with a y in the denominator, and we'll guess an a on top. We will have a term with a y plus 2 in the denominator, with a b on top, and there'll be a term with a y minus 3 in the denominator with a c on top. Now with our strategy, we put them back together over the original denominator and see what happens with our terms. So a will be multiplied by a y minus 3, b, y minus 3, and a y plus 2, excuse me. B will be multiplied by a y and a y minus 3, and then c will be multiplied, might need to get a little bit more space there, by a y and a y plus 2. Great. Now let's think about when I put things back together in the numerator here, when I expand that out, the largest one I'm going to have is a y squared term. And so let's think about y squareds. To do that, it will be helpful to factor these things out. Now things get tough horizontally, so let's just think about, I might sort of say, let's talk about the yellow triangle term for a minute. So just a little bit of side work. That is going to be a times y squared minus y minus 6. And if we expand, say, the green circle term, that will be b times y squared minus 3y. And then if we expand, I don't know, what's another shape? A blue happy face. We would have c times y squared plus 2y. So we'll track that. Now when we want to think about, for our partial fraction decomp, what are our y squared terms? In my original, I have 4y squared, so I'm going to call it 4. In my guesses, I have a times y squared, so there's a plus b and plus c. So all three of them show up. La-dee-da. What's our y term? In the original, it's negative 7. And my guesses, I have a minus a minus 3b plus 2c. And what is our constant term? In the original, it's negative 12. In this problem, we're a little lucky-ducky because a is the only one with a constant, and so it'd be negative 6a. So this is what we get to solve today. It makes it nice for us because when we solve this, we recognize the a is already solved, so a is 2. That changes the top two equations to this. 4 equals 2 plus b plus c. Negative 7 equals negative 2 minus 3b plus 2c. And we're going to just stick those back together, simplify them a little bit. So we'd have 2, and we'd have a negative 5. Great, now how do we get these to go away? Well, we have a system of equations. I'm going to add 3 of the top to the bottom. So adding 3 of the top to the bottom, I get 1. So 6 plus negative 5. 0 b's and 5 c's. I thought there were 7 c's. Me hearty. So c would equal, in this case, 1/5. If c is 1/5, then looking at the top equation, 2 plus 1/5 plus what is equal to 4. So b would have to be 9/5. That's what I got. Is that correct? I don't know. Let's stick these into our problem now and try to integrate here. So our original equation can now turn into this. The integral from 1 to 2 of 2 over y plus, we'll call it 9/5. I'm going to do it 9/5 times 1 over y plus 2 plus 1/5 times 1 over y minus 3 dy. All right. Bob's your uncle. Let's integrate these. 2 divided by y turns into 2 natural log of y. 9/5 divided by that is 9/5 natural log of y plus 2. And 1/5 natural log of y minus 3. And we're plugging in, a 1 and a 2. One thing that's important here, this doesn't often show up in our problems. Now, technically, when we do these, the integral, these should technically be absolute values of natural logs. And this is a place where it will really show up. I often ignore that just because I don't want to pay attention to it. The reason that's going to be important is just when I plug in the 2 and 1 over here, I'm going to end up with a negative number, which the natural log is not defined for. But the integral under that curve is really the absolute value of that natural log. Yeah, great. So let's look at what we got here. So we have, plugging these in, 2 natural log of 2 plus 9/5 natural log of 4 plus 1/5 natural log. When I plug in the 2, it would give me -1, but we need the absolute value, natural log of 1, which turns out that it goes to 0. So I'm just going to whatever that means. Subtract off, plug in the 1s. 2 natural log of 1. Well, that's also 0. Natural log of 1 is 0, so we're going to ignore that for a second. Plus 9/5 natural log of 3 plus 1/5 natural log of 2. And we'll call that a day. It's a day. Let's shrink this a bit. So number 4, this is one that, I feel like at the end of the semester we've been thinking about a lot of things, so we haven't done much with the long division. This one does require it. I'm not going to quiz on the long division, but let's do this. So because the degree is higher here, I would want to start this problem before I do the guesses for partial fraction decomp by doing some long division. So I'm going to rewrite this and say, use this form. X squared minus 2x plus 1 is going to go into this thing here. Now this is going to get long, so I'm going to make it small. I'm going to try to write small. If you need to zoom in on your screen, you guys actually probably have better eyes than I do, so you can do whatever you want. I'm going to ask, looking at the first term, x squared, how many x squared is going to x to the power of 4? The answer is x squared times that would give me x to the power of 4. So just like with long division, I'd say how many times does it go into that? I multiply x squared by the original term, so I get x to the 4th minus 2x cubed plus x squared. That's really cool. This actually indicates that we could have been clever, which I wasn't, and spotted a little shortcut here because all these are going to go away. So this is just a flat up 0. Because we get down. And so what I would then do is say, well, let's bring down the next term we have. And the next term we have is 2x minus 1, which is already a smaller degree than the x squared. So that's a remainder. So that tells us that this problem could actually be written as something a little bit nicer, as x squared plus 2x minus 1 over x squared minus 2x plus 1. Where the cleverness could have shown up is if I recognize that those first terms, x to the 4th minus 2x cubed plus x squared, is really the denominator times x squared. And so that part, I can get a little bit of that to cancel. But hey, you don't have to be clever if you're consistent. All right, so the x squared comes. So now we're ready to do the partial fraction decomp. For number 4, we don't have to solve it all the way. We just have to put in the form of the partial fraction decomp as was done in example 7. So where's the a's and the b's? So this is going to be x squared. Now for this partial fraction decomp, we do have to factor the bottom and recognize the bottom is really x minus 1 squared. So it would tell me this. I need one term that's an x minus 1, since it is a repeated linear term, I would also need to guess that's an x minus 1 squared with an a and a b, and then Patricia's your aunt. You're done with 4a there. So that one was a little bit tricky. Let's look at 4b. B says this, we have an x squared minus 1 over x cubed plus x squared plus x. The degree on top is higher, so that's pretty hunky-dory. Let's just look at the denominator for a second and say, well, how can I factor this out? I could pull an x out of there, and then I would have x squared plus x plus 1. And I could ask myself, does this x squared plus x plus 1, does that factor? Can I factor that down into smaller terms, or is it irreducible? One way you could always check that is thinking about in your quadratic formula, what's under the square root sign? You remember it's always b squared minus 4ac. In this case, that would be 1 squared minus 4 times 1. So that would be negative 3, which is an imaginary number. And so that indicates there is no way of reducing that. So we're ready to do the guess. So the form of partial fraction decomp would say, well, we have here a term that's a linear term x, so it gets an a on top. So the numerator is always 1 degree less than the denominator for our guesses. All right, and now the other term is a quadratic term that's not reducible, and so our guess needs to be a linear term, bx plus c. And then you're done with 4. Good job, guys. I'm doing these a bit out of order, but let's look at number 2, x over x squared plus x minus 2. Numerator is the smaller degree. Let's factor the bottom if possible, and in this case it will be. So two numbers that multiply into negative 2 but add into positive 1 would be positive 2 and negative 1. So the guess would just be a over x plus 2 plus b over x minus 1. That's part A. Part B, which clearly is the green part, is a little bit different. So it's x squared divided by x squared plus x plus 2. A few things here that are different. One, the numerator and the denominator have the same degree. We need to reduce this. I'm asking how many times does x squared plus x plus 2 go into x squared? Now I could do long division. Here's another trick. I'm going to add x plus 2 and subtract it. So that's just adding 0. And that makes this first part match the denominator. So this would turn into then 1 plus negative x minus 2 over x squared plus x plus 2. Great. Now x squared plus x plus 2, is that reducible? Thinking about that discriminant, b squared minus 4ac, that'd be 1 minus 8, negative number under the square root, therefore irreducible. And so we're actually done with that process. Like if you try to do partial fraction, you're actually already where your goal needs to be, because you can't reduce this anymore, and you have just a linear term on top. To make that obvious, the 1 would come along, and I would have as a guess here for this fraction, ax plus b over x squared plus x plus 2. But clearly the a is a negative 1, and the b is a negative 2. Hopefully this is helpful. If it's not, you can complain to Mr. Alex Glenn. He's the one. Field all complaints to Alex Glenn. Cheers.